Okay, hopefully you had a chance to get caught up with part 1 of lesson 1-6. Now I would like to show you part 2. So I gave you an introduction of polygons, some of the wording that goes along with polygons. Now we're going to move into some general formulas, okay? First of all, before we get into formulas, let's first talk about what perimeter is and then what area is. I know you guys know what these words are, but let's just refresh, okay? So perimeter is basically the distance around a figure, okay? So typically in a polygon, you add the sides. Okay, so that's how you figure out perimeter. So think of perimeter as like if you were to fence in a yard, okay, the fence would go along the perimeter. All right. An area then is going to be the amount within a figure. Okay. So if we use, like I was talking about the yard, okay, the perimeter, like let's say you have, you know, a rectangular shaped yard or some sort of yard that looks like that. It's not a true rectangle. The perimeter would be the fence along the yard, right? The area is like the grass in that yard, okay? So that's the area. So that's the difference. Alrighty, so perimeter, like I said, you're going to add up all the sides. Now the only one that's going to be a little bit different is going to be a circle, right? And a circle technically is not a polygon. However, it is included in this section. So with a circle, we talk about this idea of circumference. Okay, that's basically just the perimeter of the circle. Okay, so that distance around a circle. So the circumference, we use a capital C. You can either think of it as 2 times pi times the radius. Remember, the radius is from the center out. Okay. Or it can be pi times the diameter. Okay, so if this is our circle, here's the center. The diameter goes through the center, but it's that whole, like from end to end. Okay, so either one will give you the circumference. It just depends on the information that you're given. All right, so that's really the only, I guess, perimeter kind of formula, and that's for the circumference. Otherwise, you just add up all the sides. Okay, let's talk about some area formulas, and then I'll show you some examples here. Okay, so here are some of the basic area formulas that I'm sure you guys have seen before. We'll just do a little bit of a refresher. The first is a triangle. Okay, so I'm actually going to do I'm going to do 3 triangles to show you. Then I'll do one that looks like that. Okay. The area formula for a triangle, regardless of what kind of triangle it is 1/2 times base times height. Okay? Now the important thing to remember is that in a triangle, if this is the base, the height needs to make a 90-degree angle with the base. Okay, so in that triangle, that would be, you know, that relationship that we're looking for. In a right triangle, if this is the base, this is the height. You already have that right angle in there. It's kind of built in. It's kind of nice. Okay? In this one, if that's the base, again, the height is going to be straight down and make a 90-degree angle, or what we call perpendicular, with the base. All right? The next one, either a rectangle or a square. It works for both. The area is base times height, or length times width, you may have heard. Okay, so just like in a triangle, you want the base and the height to make a 90-degree angle. Well, in a rectangle and a square, those are all kind of built in already. So if this is the base, that's the height. You got a 90-degree angle right there. In a square, same thing happens. Okay, you have a base, then you have the height. It's built in for you. Okay? So triangle, rectangle, and then the other one, and this one, again, I know I talked about this with the circumference. A circle is not technically a polygon, but it is included in here. Okay, so for a circle, every circle has a center. I know that's not a perfect circle, but it looks more like an egg. The area formula for a circle, you may have remembered, is pi r squared. Okay? So on your calculator for the area of a circle or the circumference of a circle, just use your pi key. If you don't have your calculator and you want to multiply by 3.14, that's fine. Otherwise, feel free to use that pi key and kind of get used to using that. All right? Okay, let me show you some examples here. Here's the first one. For these, we want to find perimeter slash circumference, because I'm going to do a circle. So the perimeter, circumference, and the area. Okay, so here's the first one. I have a rectangle. This is 2.3 centimeters, and this is 4.6 centimeters. Okay, so let's find the perimeter first. Well, in a rectangle, we know that the opposite sides are going to be congruent. Okay, so what that means is if I have that one side that's 4.6, well, that means that the side opposite that is also going to be 4.6. So that means that that's also 4.6 centimeters. In the same way, if this side is 2.3, well, this side is also 2.3. Okay, so now for perimeter, we use a capital P to represent perimeter. We just need to add these sides up. Okay, so you're just going to take 2.3 plus 4.6 plus 2.3 plus 4.6, and you should get 13.8 centimeters. Okay, let's try the area. All right, so area is base times height. Okay, so we have a base, we have a height, or you can think of this as your base and that is your height. Either way, you get the same answer. So 4.6 times 2.3. All right, so when you punch those in or you do those by hand, either way, what you should get is 10.58, and remember that area is a squared unit, so I'm going to go square centimeters or centimeters squared on that one. Okay, how about a circle? We're going to have a circle that has a radius of 4 inches. It's not a bad circle. Okay, so let's find the circumference first. So circumference is 2 times pi times the radius, which in this case is 4. Okay. So I'm going to punch that in my calculator, and I'm going to round it to approximately 25.1 inches. Okay, so that's circumference. Area, remember, is pi times the radius squared. Okay, so pi times 4 squared, or you can go like pi times 16, which is the same thing as 4 squared. This one is 50.3 square inches when I round to the 10th. Okay? Awesome. My last example, you are going to have to use the distance formula on this one. Here's what this one looks like. Okay, we want to find the perimeter of ABCDE with A at 0, 4, B at 4, 0, C at 3, negative 4, D at negative 3, negative 4, and E at negative 3, 1. Yikes. So this one looks like we're going to have 5 sides, right? Because we have 5 vertices. So it's some sort of pentagon. I have no idea what it looks like. I'm just going to draw just like a rough sketch so that I can see what sides I'm talking about. So A, B, C, D, E. Notice I go counterclockwise or clockwise around. Okay, that's how you want to label yours. So this is our task. We need to try and figure out the length of each of these sides. So that means we need to figure out AB. Then we need to figure out BC. Then we need to figure out CD. And then DE. And finally, AE. So what does that mean? Distance formula 5 times. You got it. Let's get cracking. Distance formula for AB. So A and B. So 4 minus 0 squared plus 0 minus 4 squared. So I get 4 squared plus negative 4 squared. So that's 16 plus 16, which is the same thing as square root 32. If I put that in to get a rounded answer, it's about, I'm running out of room here, 5.7 rounded. Okay, so that's AB. So 5.7 is AB. And now we're going to do it again. BC. So I'm looking at these 2 points. 3 minus 4 squared plus negative 4 minus 0 squared. So that's the same thing as negative 1 plus negative 4. Square both of those. So we get 1 plus 16. That would be 17. Square root of 17 is 4.1. So this side is 4.1. Next, CD. So we're going to use these points. Alrighty. Negative 3 minus 3 squared plus negative 4 minus negative 4 turns it to a plus 4. So I'm going to write it like that. So we get negative 6 squared plus, oh, nice. I love zeros. Square root of 36, 6. Okay, we're getting there. DE. So now the last 2 points, negative 3 turns into a plus 3 squared plus 1 minus negative 4 turns into a plus 4. Okay, 0 plus 5, 25. Square root of that is 5. Last one, A and E. So 0 turns into a plus 3 squared plus 4 minus 1 squared equals, let's see, this would be a 3 squared and another 3 squared. So that's 9 plus 9, 18. The square root of 18, 4.2. Okay, my last step is to add them all together, and then you have the perimeter, and I'm running out of time, so I'm going to let you guys do that. All right, so use the rest of the time, if there is any, to work on your assignment, and I'll see you later. Bye.